Okay, after all of the very math-intensive examples that we've seen in this section, we're now going to return to a word problem dealing with compound interest. This word problem is actually a continuation of a problem we saw in the previous section. So the problem says, assume that $650 is invested into an account earning interest at a 6% annual rate compounded continuously. So just like we saw in the last section, if we have continuous compound interest, our formula for the value of the account at time t is going to look like this. So A of t is equal to 650 times e to the 0.06t. This gives us the value of the account t years after the money was invested. So what I actually want here in this problem is we want to know how long it takes for the value of the account to be equal to some certain amount. Now this is different. This is kind of backwards from what we were doing in section 2.5. In 2.5 we were given t, we were given a time, we plugged that in and then found the value of the account. Now we're given the value, we want to somehow use that to find t, find time. So in part A, we want to know how long it takes for the value of the account to be $975. So that means we plug 975 in for A of t, which is, again, the value. So that gives us this equation we need to solve. So part 1, I divide both sides by 650. So I just divide both sides by that 650 to get rid of that. And I believe that's going to give me 1.5 equals e to the 0.06t. Now, the t that I need to solve for is up in an exponent. So to get it down, I need to use a logarithm in some way. Since my base is e, that's nice. That means I can just take a standard natural logarithm and it will cancel out with the e. So I need to take a natural log of both sides. And that gives me ln, let me fix that, ln of 1.5 equals 0.06t. So I can divide both sides by 0.06, and that's going to tell me that t is equal to the natural log of 1.5 divided by 0.06. Or in other words, t is 6.76, rounded to 2 decimal places, and t is always measured in years in this problem. Okay, so it would take 6.76 years for my $650 to grow to $975 at a continuous rate of 6%. Okay, part B, we want to know how long it would take for the account to grow to $1,300. So 1,300 equals 650 e to the 0.06t. Well, this problem works out very similar to the previous one. I divide both sides by 650, and that gives me 2 equals e to the 0.06t. Then I take a natural log of both sides. On the right-hand side, the natural log and the e simply cancel. So that gives me the ln of 2 equals 0.06t. And then I divide both sides by 0.06. So the ln, I get ln of 2 divided by 0.06. And in this case, t is equal to 11.55. Okay? So it takes about 11.5 years for the value of my account to double, to grow from $650 to $1,300. Okay? Well, you probably already get the gist of how this works. For the sake of argument, let's do 2 more examples. Part C, we want to know how long it takes for the account to grow to $1,625. So it's the same exact process, just with different numbers. I divide both sides by 650. 1,625 divided by 650 is 2.5. So I get 2.5 equals e to the 0.06 t. Now I take the natural log of both sides. The natural log and the e cancel on the right-hand side. So I have ln of 2.5 equals 0.06 t. Then divide both sides by 0.06. Natural log of 2.5 divided by 0.06. And I get that t is 15.27. Okay, one last example. We want to know how long it takes for the account to grow to 1950. So in other words, this is asking how long does it take at 6% compound interest compounded continuously? How long does it take for the value of your money to triple? Because if I divide both sides by 650, I get 3 on the left-hand side. So 650 times 3 is 1950. I want to know how long it takes for the value of my investment to triple. So I take the natural log of both sides, just like in the previous parts, and I get ln of 3 equals 0.06 t. T is the natural log of 3 divided by 0.06. So t is 18.31.